Okay, hello everyone. So we're going to be continuing our solving by looking at the inverse 2b there. So by calculating the inverse of 21 mod 37, right? Well, what is the inverse? Well, the inverse is a number such that if we have 21 by that inverse x, right? By that inverse we call it x. I mean that should be congruent to 1 mod 37 like that. Basically, what we have is that it's a number where if we multiply 21 by 8 and then we find the remainder, right? If we have 21x mod 37, the remainder should be 1. Basically, that's what we want to calculate, right? That's what we want to calculate. Now, the way we do this is by finding the is by using the GCD and the reverse Euclidean algorithm. Okay, so first thing we're going to do is I'm going to say this 21, right? So 21 x, this is the same as us saying 37 by some y plus 1 there. So meaning 21x minus 37y is equal to 1 there. So we want to find x and y in this situation, right? These are things that we want to end up calculating. Okay, so how are we going to do this, right? How are we going to do this? That's a quick reminder. The inverse should be less than 37 if I'm not mistaken. So first of all, we're going to use the Euclidean algorithm. Right? I'm just going to go to the next page. So we're going to say 37. 37, if we divide it by 21, right? 27 divided by 21, this is 21 by, I'm going to be using a different color here. 27 there by, this is 1, right? Plus what will our remainder be? Our remainder in this case will be 16. This 21 as well can then be expressed as 16 by what? By 1 plus a remainder 5, right? This again, 16, can be expressed as 5 by what? By 3 plus a remainder what? 1. Then the moment you get your remainder 1, you can end here, right? Because the next part will just be 1, what is 5 is equal to 1 by 5 plus 0. So we can't go any further than this. So in order to get here, and this is also our GCD. So this is how we find your GCD using the Euclidean algorithm. So 1 is our greatest common divisor. So the greatest common divisor is basically the point where if we have, as I said, 5 is equal to 1 by 5 plus 0. Basically, if you get a 0 here, meaning your previous remainder here was the GCD. So that's how you calculate GCD. But that's not what we're looking for. So the reverse Euclidean algorithm basically says, okay, we have this. Now let's start going in reverse. And by inverse we mean we're going to start calculating this remainder over here, right? We're going to equate everything to the remainders. That means I'm going to say 16 is equal to what? 37 minus 21 by 1 there, right? We have that there. Okay, this is then equal to, okay, so we have 16 there. We can't further elaborate over this one. We're going to move on to 5. 5 is equal to 21 minus 16 by 1. Okay, good. Now, what is 16? 16 is that. So we're going to say 21 minus, we're going to say 1 there by, right, which is just, of course, the number itself, 37 minus 21, right, 27 minus 21 by 1 itself there. Okay, we're going to have that there, which is then just going to be 21 by, what is 1 multiplied by this is just 37 itself. Then this is plus 21 by 1. The 1 remains unchanged there. You can even just be leaving it out, but anyway, which is then just, so what we have here, you can think of this 31 as being something like A, 21 being something like A, and then 37 being something like B. So what do you have when you have A plus A? This is just 2A, right? A plus 2A is just 3A, right? Basic algebra there. How we're going to be doing. So we want to maintain our 21 and 37 there. So 21 plus 21 there, it will just be 21 times 2, right? 21 times 2 minus 37, like that there, right? So we have that there. Then now what we're going to say is that, okay, we have 5 there. What's the next part? This one here, where we ended things. So I'm just going to split my board. Can do the rest of the steps here. So moving on from here, we have 1 is equal to 16 minus 3 there, and then a 5, right? So 3 by 5. Now what is 16? 16 is that. So we're going to have 37 minus 21 by 1 there. Then minus, open brackets. What's going to be in those brackets? We're going to have the value of 5, which is 21 by 2, right? 21 by 2 minus 37, right? By this 3 over here. Let's not forget the 3 outside there. So I'm just going to put 3 there, right? Okay. Then now, next thing I'm going to do is that, okay, I'm going to say, okay, this is then equal to 37 minus 21 by, I'm going to put the 1, so 21 by 1 there, minus, then we're going to have this times that, 3 times 2 is 6 there, right? Times 2 is 6, so we're going to have 21 by 6 there. I'm supposed to be colored. 21 by 6, then it will be 37 by 3 there, so it's going to be, let me just put the 3 here. I still have the red pen. Then I'm going to have 37 plus there. Okay, now I'm just going to quickly, so for this, so we're going to have 37 by 4, right? 37 by 4. Then this is going to be minus 21 by what? By 7, right? Now, what this implies is x is equal to negative 7, right? X is equal to negative 7. But we don't want that negative, so how do we get rid of it? Well, the easiest thing is just to say 37 minus that, right? So just want you to remember, this is the same as what we're doing there when we say 4 mod 5 is equal to negative 1 or 4. It's the same thing that we have here, because to calculate for this, to calculate for 4, we just had to add these two. So sort of basically doing here. So what we're going to do is, we're just going to say this is also equal to 37 minus that there, which is just 30, right? Which is 30. So therefore, inverse, so inverse, what is inverse 21 mod, inverse 21 mod 37, or you can say 21 inverse, right, is equal to, or is congruent to 30 mod 37. So it's how we find the inverse. Again, we're going to be using this when we start looking at encryption. So most of these things, we're just saying them now, but as we go into encryption, they're going to become more and more and more useful. So yeah, this is how you find the inverse. That's it for this question. Yeah, bye.